Astronomers have gained the biggest glimpse into the past to date by measuring the light from a star that exploded 13 billion years ago, shortly after the beginning of the universe. We're talking about the Big Bang, marking the history of one of the most, or let's say the most extreme explosions in the universe. Get to know more about the extreme explosions in the universe as you watch this video to the end. But before we start, please like and subscribe to this channel, and then sit back and relax. Now let's go back in time to the occurrence of the Big Bang. How did the Big Bang explosion originate? The Big Bang theory, although it explains the origin of the universe, raises a big question. What caused the Big Bang? Three researchers from the Perimeter Institute for Theoretical Physics in Canada propose an eccentric answer. According to Rezi Porhasan, Naish Afshordi, and Robert Mann, what we perceive as the Big Bang could be the three-dimensional mirage of a collapsing star in a universe radically different from our own. The Big Bang is believed to have started with a space-time singularity, which is a phenomenon where the normal laws of physics are broken. Singularities are extremely rare, and our understanding of them is limited. According to the authors, the Big Bang hypothesis has a fundamental problem. It is relatively comprehensive and uniform. It seems unlikely to them that a predictable universe would emerge from the chaotic destruction of a singularity. Perhaps our universe was never singular, but the three-dimensional envelope around the event horizon of a four-dimensional black hole. An event or event horizon refers to the boundary of spacetime that marks the entry of a black hole. In theory, nothing, not even light, can escape them. In this scenario, our universe existed after a four-dimensional star collapsed into a black hole. It originated as, and still is, a single feature in the debris of the stellar implosion. The researchers stress that this idea, while it may sound absurd, is based on modern mathematics that describes space and time. Big Bang, known as the Big Explosion, as defined by scientists. A team of scientists from the University of Florida, USA, has been able to discover in their laboratory the necessary conditions for an explosion like the Big Bang to occur. One of the great unknowns of our existence is how the universe originated, and with it our existence. How is it possible that stars, planets, and galaxies formed? To find answers to these questions, the famous theory of the Big Bang, or Big Explosion, arose. Can this theory explain the origin of the universe? They argued that the universe, as we know it today, originated 13.7 billion years ago as a result of a huge explosion in space known as the Big Bang. However, why did this explosion happen? A flame can accelerate and explode by itself. Now there may be an explanation for all this. A team of scientists from the University of Florida, USA, led by Dr. Kareem Ahmed, has been able to discover by chance in his laboratory the conditions necessary for an explosion like the Big Bang to occur. Researchers were immersed in tests to produce hypersonic jet propulsion when they discovered that a flame could accelerate and explode on its own. They explored these supersonic reactions for propulsion, and as a result, they found a mechanism that seemed very interesting. With that, they started digging deeper, and they realized that this relates to something as deep as the origin of the universe. The work method. What did the investigation consist of? The team of scientists applied just the right amount of turbulence and mixed it with an unconfined flame to make it self-perpetuating. The flame began to burn the ingested energy, resulting in a hypersonic supernova explosion. These scientists defined the fundamental criteria by which they can drive a flame to self-generate its turbulence, spontaneously accelerate, and go to detonation. Furthermore, they used turbulence to enhance the mixing of the reactions to the point where it turned into this backlash and essentially led to supernova, which exploded stars in simple terms. This recent discovery could mark a before and after in the history of science by being able to corroborate how our entire universe originated. Now that you know about the Big Bang explosion, these are the most terrible explosions in the universe since the Big Bang. Huge amount of energy. For years, scientists thought there was something strange about the Ophiuchus cluster of galaxies, which is a giant congregation containing thousands of galaxies interspersed with hot gas and dark matter. X-ray telescopes in the US and Europe had seen a curious curved edge on them. It was speculated that it could be the wall of a cavity generated by emissions from a gigantic black hole in one of the central galaxies. Black holes are famous for ingesting matter, any gas, and even stars that come too close to them. But at the same time, they are capable of ejecting prodigious amounts of material and energy. At first, scientists doubted the black hole explanation because the cavity they found inside the galaxy was so large. This implied that the emission of energy must have had an almost unthinkable dimension. However, low-frequency telescopes located at the Murchison Wide Field Array (MWA) research centers in Australia and the Giant Microwave Radio Telescope (GMRT) in India helped confirm this theory. Black holes are capable of ejecting prodigious amounts of material and energy. According to Johnston Hollett, who heads the MWA, this object was previously observed by another team with the Chandra X-ray telescope. They saw this bubble in the center of that cluster of galaxies and said, well, this can't be due to one of those energetic emissions because it must have been huge. The scale would be inconceivable. So they ruled out that possibility. But they went back and looked at it with low-frequency radio telescopes and found that this cavity is filled with radioplasma. The amount of energy it took to create this cavity within the galaxy cluster far exceeds the previously recorded record, which occurred in another galaxy cluster known as MSO 735+74. In a way, it's like when the eruption of St. Helena, a volcano in Washington state, in the United States, left the mountain without a peak. The Fast Radio Burst, FRB. At the end of September 2007, we became aware that a new phenomenon had appeared in the sky, something that astronomers did not even know existed. It all happened when the astrophysicists Duncan Lorimer and David Markovic reanalyzed the data received 6 years ago at the Parkes Radio Telescope in Australia and found a tremendous explosion that occurred at a distance of 1,500 million light-years. In the 5 milliseconds that it lasted, the same amount of energy that our Sun emits in 15 days was released. How could the astronomers who collected the observation data in 2001 miss something like this? They didn't get over it, but they dismissed it because they thought it was some kind of terrestrial radio interference. They didn't get that such a phenomenal burst of energy had a cosmic origin. These are the Fast Radio Burst, FRB. Despite the stillness of our night sky, the universe is not a quiet place. Quite the contrary, still awaiting Betelgeuse. Some stars explode at the end of their days, becoming as bright as all the stars in the galaxy combined. That is the fate that awaits, either tomorrow or in the next 100,000 years. Betelgeuse, a bright star in the constellation Orion. When it happens, it will be as bright as the first quarter moon. Gamma ray burst, GRB. But in the cosmos, there are other more terrible explosions, such as the so-called gamma ray burst or gamma ray burst, GRB. On average, once a day, at some point in the sky, and for a period of time ranging from a fraction of a second to a few minutes, the universe gifts us with something that emits as much energy as 200,000 Milky Ways together. Little did we know about the origin of these GRBs until January 23, 1999, when space-based X-ray and gamma-ray observatories detected an impressive energetic flare at a point in the sky located in the constellation Boyero. 2 waves of radiation reached Earth 25 and 40 seconds after the explosion began. Over the next 50 seconds, other weaker pulses came until finally there was calm. Calculating the energy released, the result was impressive. If it had happened just 2,000 light-years away from us, a star twice as bright as our own Sun would have appeared in the sky. Hidden behind those unattractive names used by astronomers to catalog celestial events, GRB 990,123 will go down in history for being the first time a GRB was observed in the range of visible light. It was so bright that it could have been seen with good binoculars if we had known where to look. GRBs were detected for the first time on July 2, 1967, by the U.S. Vela 3 and Vela 4 satellites, which were intended to measure gamma radiation produced by Soviet nuclear tests. That day they detected a flash of gamma radiation whose structure did not conform to what was usual for atomic explosions. We had to wait more than 30 years for that January 23, 1999, to be able to photograph this cataclysmic phenomenon, and thanks to this, identify its origin. A very faint galaxy located 9,000 million light-years away. Now, what happened in that distant galaxy for something to shine as bright as 200,000 Milky Ways put together? This is where we have the mystery. Some astronomers think it was a hypernova. Its name comes from a comparison with supernova, the most apocalyptic end that a star can have. When its nuclear fuel is finished, it explodes, becoming as bright as a billion stars. Well, a hypernova is at least 100 times more intense. Nobody knows how and why it happens, but it is assumed that it occurs when the most massive stars, with more than 30 times the mass of the Sun, collapse to form a black hole in a process that lasts 10 to 20 seconds. They are difficult to observe because they are so rare. One appears for every million supernova. On the origin of the FRB and GRB, there is no consensus on who can cause such deflagrations. In addition to the hypernova hypothesis, there is that of the collision between two neutron stars, stars with 1.5 times the mass of our Sun packed inside a sphere 10 kilometers in diameter. This very exotic collision and its detection from gravitational waves was the reason for the Nobel Prize in 2017, which was one of the explanations offered by Duncan Lorimer, director of the group that discovered this unusual phenomenon. Of course, he has also proposed another even more striking explanation, that the last death rattle of a black hole when it completely evaporates. Lorimer is referring to what is known as Hawking evaporation, a mechanism described by the famous British physicist by which a black hole continually loses energy until it disappears with a huge gamma-ray burst. However, the calculations carried out by theoretical physicists reveal that a black hole of about 3 solar masses will disappear after a whopping 1066 years have elapsed. That is, 1,000,000 trillion years. How can we be observing evaporation now? Because if the theoretical predictions are correct, huge numbers of tiny, mountain mass black holes were created during the Big Bang. It is these, at this moment, who would be evaporating, releasing large amounts of gamma radiation in an infinitesimal second, as is being observed. The only problem with this is that micro black holes are still an untested theoretical prediction. If you enjoyed this video, don't forget to hit like, the subscription button, and the notification bell to get notified when new videos are uploaded from this channel. Please share your thoughts about the most extreme explosion in the universe in the comment section below. Thank you.